By now, we're used to seeing functions defined like h of y is equal to y squared, or f of x is equal to the square root of x. But what we're now going to explore is functions that are defined piece by piece over different intervals. And functions like this are, you'll sometimes view them as a piecewise, or these types of function definitions, they might be called a piecewise function definition. And so let's take a look at this graph right over here. This graph, you can see that the function is constant over this interval for x, and then it jumps up to in this interval for x, and then it jumps back down for this interval for x. So let's think about how we would write this using our function notation. So if we say that this right over here is the x-axis, and if this is the y is equal to f of x axis, then let's see, our function f of x is going to be equal to, let's see, there's 3 different intervals. So let me give myself some space for the 3 different intervals. Now this first interval is from not including negative 9. I have this open circle here, not a closed-in circle. So not including negative 9, but x being greater than negative 9 and all the way up to and including negative 5. So I could write that as negative 9 is less than x, less than or equal to negative 5. That's this interval. And what is the value of the function over this interval? Well, we see the value of the function is negative 9. It's a constant negative 9 over that interval. It's a little confusing because the value of the function is actually also the value of the lower bound on this interval right over here. And it's very important to look at that this says negative 9 is less than x, not less than or equal. If it was less than or equal, then the function would have been defined at x equals negative 9, but it's not. We have an open circle right over there. But now let's look at the next interval. The next interval is from x is greater, or negative 5 is less than x, which is less than or equal to negative 1. And over that interval, the function is equal to, the function is a constant 6. It jumps up here. Sometimes people call this a step function. It steps up. It looks like stairs to some degree. Now it's very important here that at x equals negative 5, for it to be defined only one place. Here it's defined by this part. It's only defined over here. And so that's why it's important that this isn't a negative 5 is less than or equal to, because then if you put negative 5 into the function, this thing would be filled in, and then the function would be defined to both places, and that's not cool for a function. It wouldn't be a function anymore. So it's very important that that when you input negative 5 in here, you know which of these intervals you are in. You can't be in two of these intervals. If you are in 2 of these intervals, the interval should give you the same value so that the function maps from one input to the same output. Now let's keep going. We have this last interval where we're going from negative 1. We're going from negative 1 to 9, from negative 1 to positive 9. And x, it starts off with negative 1 less than x, because we have an open circle right over here. And that's good because x equals negative 1 is defined up here, all the way to x is less than or equal to 9. And over that interval, what is the value of our function? Well, you see the value of our function is a constant negative 7. A constant negative 7. And we're done. We have just constructed a piece-by-piece definition of this function. And actually, when you see this type of function notation, it becomes a lot clearer why function notation is useful even. And hopefully, well anyway, hopefully you enjoyed that. I always find these piecewise functions a lot of fun.